Warning, the video you're about to watch contains mathematics at the level of integral calculus, also known as Calc 2. All material has an assumed prerequisite of differential calculus and a full semester course in trigonometry. A thorough review of prerequisite topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This video is meant for Calc 2 students who are going through arc length functions, or at least arc length content, in the middle of their Calc 2 course, or if you're one of my students, at the end of our Calc 2 course. This specific example I'm doing here is for the arc length function itself. So a lot of students know that the arc length, or how you compute the arc length for a given function, is the following. The length of an arc from either x equals a or y equals a to x equals b, or again y equals b, is just the integral from a to b of ds, where ds is variable. It just depends upon how you're going to integrate. For example, if you want to integrate with respect to x, then you use this version of ds. And by the way, if you want to know how this formula is derived, you can look it up online. I actually didn't record a proof of this. Instead, I just proved it for my students in class. However, it is the Pythagorean theorem, essentially. So the other way that this can be written is like this. And this, you would use the second version if you're going to integrate with respect to y. As I've told my students, don't always assume that you're going to integrate with respect to x just because somebody handed you y is equal to something with x. That is a common mistake. It's a good idea to test both ways to see which one provides a better integrand. Now, this arc length function would be great if somebody told me I'm integrating from, let's say, 0 to 10 or some silliness like that. Or in this case, I suppose you don't want to go from 0 to 10 because you have some issues at some values beyond 0. The cosine specifically at pi over 2 is 0 itself, and the natural log can't have an argument of 0, so that would be a problem. However, in this case as well, they're not asking for the arc length value, they're asking for the arc length function. And this is just a minor difference between the arc length of a function over a given interval or the arc length function. In this case, we want to write a function of x that will return the length of the arc when we plug in x. We're going to start the length of our arc at x equals 0. We're going to end before we get to pi over 2. And we don't know exactly where somebody wants us to end, but it has to be before pi over 2. So the way you would write this is you'd say, I'm going to integrate from x equals 0, or probably it'd be better to say you're going to integrate from 0 to x. Now you should know from your Calc 1 material that you cannot have a limit of your integral be the same value that you're integrating with respect to. This is a no-no right here. That is very bad news. You cannot do that. Therefore, we're going to have to integrate with respect to a different variable. Now, let me just say something before we get too far. If I ask you to integrate from 1 to 10 of x squared dx, those x's, they're just letters. Nobody really cares about them. They're just variables. They're placeholders, if you will. That would be the same integral as 1 to 10 of t squared dt, or the integral from 1 to 10 of happy face squared d happy face. That is just a placeholder. Those are pictures that just allow us to kind of do the work we need to do to be successful with this content. So don't get married to the idea that your variable always has to be x. In this case, we're going to integrate from 0 to x the arc length. And very specifically here, I'm going to choose the arc length function to be a function of, let's just make it a function of t. So I'm going to change this f of x to be an f of t. And so I know that I will go ahead and replace this. I'll say I integrate from t equals 0 to t equals x of the square root of 1 plus f prime at t squared dt. Now, just as I would do in class, I'll go ahead and pre-work a lot of this information. So f prime of t is just, well, the natural derivative of the natural log is 1 over its argument. And then by the chain rule, the derivative of its argument. So you can see this is going to be the negative tangent of t. And if we square that and plug that into this function, or the integrand, if you will, you get to this point right here. Now, obviously, there's a trig identity staring at us, and I am allowed to take the square root of that square and not call it an absolute value because I happen to know that my angles that t is going to take on are between 0 and pi over 2. So in other words, quadrant 1 angles. And because they're quadrant 1 angles, the secant will always be positive. So I don't have to worry about writing an absolute value there. And now we finish this out by integrating. Remember, we're evaluating this from 0 to x. In the end, we want a function of x. We want the length of the arc, just depending upon when somebody wants us to stop. It is a known fact that we're going to stop before we get to pi over 2, so that's kind of built into the problem itself. But it's up to whomever's going to use this to tell us when they actually want to stop. We're just building this for them so they can say, well, I'm going to stop at pi over 4 or whatever. We get down to this point and we can still clean things up. For example, secant of 0 is 1, tangent of 0 is 0, and so that's just 1 within the argument of the natural log. Natural log of 1 is 0, so that second term is gone. Also, because our angles are always going to be in quadrant 1, secant and tangent will be positive. There's no real need to leave those absolute values on. You can just write it like this. Now, if you're one of my students, I wouldn't really mark you off for leaving the absolute values on there. However, it is just good to know that if you want to look ahead, or maybe you have an instructor who's a bit of a stickler, then you might want to make sure that you remove those absolute values because your angles are in quadrant 1. And this is actually the arc length function, the length of that function, which is, what is it? The natural log of the cosine of x. And it's where x is allowed to be any number between 0 and pi over 2, not including pi over 2. And that's how you do an arc length function example. Normally, like I said, you could just find the arc length because they usually say, like, find the arc length from 0 to, let's say, pi over 4. But in this case, we're building a function so that somebody else can make the determination, I want to go from 0 to x, whatever number you want to plug in for x there. All right, so I hope this video is helpful for you, and I hope you have a great day. I'll see you in another video.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Listen close, don't talk too much that isn't cold. Sure, you may really hurt inside. It doesn't justify you to speak too loud and cry.